Welcome to my RGB DAC revision 4.1 guide. So this right here is my RGB DAC revision 4.1, and I wanted to put a little guide. This is to kind of get rid of that sheet of paper that I used to include in all my DACs and just have a simple QR code on the label that people can scan in and watch this little guide on how to do it, and also what to avoid, like a warning. So first of all, these are the analog outputs, and you don't want to exceed more than 12 volts period of 150 LEDs, so no more than 150 LEDs on 12 volt. And if you're running 5 volt LEDs, you don't want to exceed more than 50. So 150 for the 12 volt rail and 50 for the 5 volt. Exceeding that and switching it to like a color like white, you could potentially blow one of the fuses on this. So I wanted to kind of go over also a little change log on this between the two different versions that I have. So this is revision 4.1 right here, and this is revision 4.0. This is the original board that we started reselling in August of 2019-ish. And the big changes are, first of all, this one actually came in two different varieties. This came in a 5 volt analog and a 12 volt analog. And we actually just shrank that into just one design where we just had a single adjustable 12 volt or 5 volts. So if you can see right here, we have a real physical jumper, and this one we just have a solder jumper. So this means that you can swap the jumper between 5 volt and 12 volt if you want to have a 5 volt analog RGB device attached to one of these headers. Well, this one you physically would have to resolder it, and that was kind of the big difference between those two revisions, two different versions, the 5 volt and the analog. So the analog 5 volt and a 12 volt analog is just this jumper right here being where the solder was, and also what type of header. On the Thermaltake RGB version, we would have like this type of header right here where you could plug in their 5 volt analog RGB fan header. So they use a fan header connector for some reason. So we just use these type of headers for that, and I'd have to manually solder these on, and I wanted something that would be easier to produce and take less time for me to do. So we decided to just reduce it to one version. And also the Thermaltake RGB fittings, I don't think they're being sold anymore, so how many could we produce? And I don't want things just sitting around not being used, but we have a solution for those who want to still use these for their Thermaltake RGB fittings and they need one. So first of all, you can just remove this little jumper right here and set it on the 5 volt rail, and then you can just remove these. And I kind of made these. I'll see if my resellers want to carry them, or you can make them yourself. You just plug them into this right here, then it plugs it in like that. I think there's also some adapter cables you can buy, but this might be the cheapest alternative. And all these are just kind of a bigger version of these vertically. So if you look, the holes on this one are slightly bigger. It's kind of hard to tell in the camera, but the holes on this one are bigger than the holes on this one. So if you can see, I can't plug this into here, but I can plug it easily into this one. So and all I did is I just got these type of headers and just plugged them in. So this is kind of a little DIY thing, but I'll see if some of my resellers want to just stock them, so people that don't want to make them can just easily buy them. And that's all you have to do if you don't have the Thermaltake. But for most of you, you're going to probably be using the 12 volt version. We do have 4 different channels right here, so if you have 4 different fans, you can actually have each fan running a different color if you have older analog fans. Set this back on 12 volts so I don't forget. Another feature is it comes with M3 standoffs and screws, nuts. So you can mount this to a 2.5 inch caddy. Granted, you can only mount right here or right here. You can't mount both of these because the spacing apart on just one side is correct, but I would have had to have a much longer board and move a lot of things around to be able to space it to fit exactly on it. I also might do a 3D like a 3D printed STL file with that way people can just have an adapter that way. So this works with pretty much any addressable RGB controller that are used by computers these days. I know some of the old, like if you have a really older Corsair Latino Pro, they do need a firmware update to be able to get it working with this, or else you might see like just all white LEDs. And that's kind of just really the big changes between it, and the just kind of warning. Again, avoid more than 150 12-volt LEDs and avoid more than 50 5-volt LEDs. So this device not only acts as a converter, but it also acts as an adapter, so you can plug an Corsair or a non-Corsair device, addressable device, on the output. Input, you can only have one input at a time because you can't take more than one signal. I mean, you could turn one signal off and the other one on. So like for the Corsair, just plug this in and plug this into here. And then you can plug your analog strips here. This uses just a standard floppy drive connector. Pretty much all power supplies still come with them. And that's how it kind of goes. So you can still output addressable signal, so it does this 4, and then this will output the next 5 through whatever, and same thing you can do that here. There's no 5-volt coming into it. 5 volts only supplied here. So if you have any questions, feel free to submit them in the comments. You can also join our Discord to ask questions, and feel free to subscribe if you want to see more content like this. Thank you very much.